You are welcome back again to a session with me, my humble self, Ada. Now, under this video, I understand we have Bece students writing their exams soon, preparing for their exams. Yes, so I have Bece past questions. Just pick some of them randomly and let's solve. I will create more as time goes on. The first question says, a man spends 1/4 of his monthly income on children's school fees and 3/5 on home affairs. What fraction is left? It's just a direct question. Yes. So all you have to do is look out for that of the children. The man spends 1/4 of his monthly income. Take his monthly income to the 1. You get? Because we're dealing with fraction. So if you have spent 1/4 on children's school fees and have spent 3/5 on home affairs, so all you have to do is you say how much is left, right? So that means you have to just say it's total spent. Total expense, let me put that. You don't have the value, but in terms of fraction, I have 1/4 plus 3/5. That will give you what? LCM here will be 20. Here, 5. 4 in 25 times 1, 5. 5 in 24 times 3, 12. And that will become 17/20. We are not done. This is a total fraction. Or, yes, by estimation, by fraction, everything spent. The fraction spent on the children's school fees plus the fraction spent on home affairs. So what fraction of his money will be left? That's the question. So we take his money to be 1 as a whole. So he has spent certain fraction out of 1 from that money. So it's like you have an orange, and out of this, let's say you have something like an apple or so, or orange, and person spent 1/4. Okay, let me draw it properly. That will not say the 1/4 on school fees, SF. Then spend 3/5. Let's take this to be, let's assume this is around 3/5. This place on home affairs, HF. So one fraction is left is this place. So if you add this to this, you remove it from the whole. This whole orange is 1. If you remove this plus this, which is 17/20, from it, you will have what is left, which is this side. Do you get? So that's the same thing we are doing. Just have one fraction is left. Fraction left. I have 1/1 minus 17/20. Take your LCM to be 20. That will be equal to 3/20. You get that? We'll move on to the next question. The next question says, okay, let me wipe this. The next question, if the bearing of A from B is 135 degrees. Now this bearing, I think that's where for GS3 and Basic 9, Basic 9 or GS3, is where the questions on bearing start from. And this is a major concept you should understand. So the bearing of A from B is 135. Let me just draw something here. This is your north, of course. This is your east. This is your south. This is your west. Right? Please manage this. Now they said the bearing of A from B is 135. A from A, but from B is 135. This place is always 90. This is 90. This place is also 90. Each of these quadrants is 90. And if you are carrying out bearing, you move clockwise. At least you move this way. You get that? Until you get back to the north. So 90 plus 90, another 90 here, plus another 90. So everything give you 360. So 90, if you're dealing with any quadrant that's between 0 and 90, to fall here. If you're dealing with any value between 0 and 180, to fall on the second quadrant. Because 90 plus 90, so the whole of this is 180. So we're looking for 135, 150 something, 170 something to fall here. Once it's more than 90 and it's less than 180, to fall here. Once it's more than 180 but less than 270, it will fall here. Once it's greater than 270 but less than 360, to fall here. Do you understand? So let's continue. So we're told that the bearing of A from B is 135. 135 will fall on the second quadrant. This is 90, 0 to 90. So this is 135. So let's pick any area convenient for us. Let's take this. 135. This is 90. 90 plus 1 will give us 135. That will be 90 plus 45. Right? So we take this place to be 45. Because this plus this will already give us 135. Note again, your bearing must always come from the north. So taking it from the north, going this way, must come from the north. So this is from here 0 to 90, then from 90 plus 45, 135. So this is B. I will call this point B. Do you get? So this is point B. Let me see if what I have is big. Okay, I think you can work with that. So B, then it now says, okay, let me make it bigger so that there won't be. So this is north, east, south, west, and this is point B. Let me call this B. So this is, oh, I want something longer. You get? So this is B. This place is 45 degrees. Then here at this point, you create another cardinal. This is a cardinal. Create another cardinal. We've gotten the bearing of A from this from B, right? Create another cardinal. This. Another cardinal is there. So this place will be A. You get? So this place will be point A. So the bearing, since the bearing of A from B is 135, from here to here is 135. Only this small angle here is 45. So by alternate angle, look at this. This is Z angle. Are you seeing the Z angle? This is Z. Are you seeing that? So that is Z angle. Z angle. This angle and this angle. They are alternate angles. So this should be 45 degrees. The question now says, what is the bearing of B from A? So what will not be the bearing of B, but from A? You also go from the north. So your bearing must always go from the north. So you go from the north, move, until you hit this line. Do you get? So this place is 90. This place is 90. This place is 90. This 45. So that is like 90 plus 90 plus 90 plus 45. Therefore, bearing of A, of B, from here now, of B, from A that will be equal to 180, 270, 270 plus 45, 11, that will be equal to 315 degrees. You get that? So it's as simple and direct as that. Thank you. The next question. Now, as to find the area of the trapezium. Now, this is a trapezium, and don't forget, if you have a trapezium, what you need is the height, you need the A, you need the B. Because the area of a trapezium is always half open bracket A plus B, then times the height, where this and this are parallel to each other, the two lines. So here, we don't have the height, isn't it? We have a triangle here. This broken line represents our height, but we don't have it. So we cannot calculate the area. But here we have 10, here we have 8. And this line is perpendicular to this line. So that means this place is 90 degrees. Of course, this is already 90, so this place will be 90. You get? So since this is 90, you can use Pythagoras theorem. And Pythagoras theorem says Pythagoras theorem states that AE squared should be equal to this length, which is the hypotenuse, where the right angle is facing the longest side of the triangle. The hypotenuse should be, the square of it should be equal to the square of the other two sides. So that would be ED squared plus AD squared. And that means 10 squared can be equal to 8 squared plus H squared. We don't have this, that's H. So that will be 100 can be equal to 64 plus H squared. So collecting like terms, 100 minus 64 can be equal to H squared. If you remove this from this, that will be 36 can be equal to H squared. So H here will be equal to the square root of 36. So our H can be equal to plus or minus 6. But here, because we are dealing with height, it will be positive. So we go with 6. Answer is 6. So now we cannot find the area of this trapezium. So area of trapezium will now be half, open bracket, A. This is my A, right? Don't forget there is 8 here. Right? So once we have this, what can we do first? We are not done. We've only gotten height to be 6. Yes, we don't still have this yet. But of course, this place and this place, they are the same thing. They are parallel, they are equal. This is a rectangle. So that will be 13 plus, this place will be 13. 13 plus 8, that will be 21. 21 plus 13 times the height. Our height is now 6. So that will be equal to 1 over 2 times 4, 34 times 6 over 1. 2 here 1, 2 here 3. So the area will be 12, 9, 102 is centimeter square. So area of the trapezium is 102 centimeter square. To the last question before we round up this session. We have these two. Now, if you look at this shape, this symbol represents equality. And this side is equal to this side. And if that side is equal, don't forget, that means that triangle is an isosceles triangle is 28 degrees. And when the two sides are equal, automatically this angle will be equal. Do you get? So these angles will be equal. That implies that I can call these angles 28 plus, let's say they are x plus x. Everything should be equal to 180. That means 28 plus 2x can be equal to 180. Then 180 2x can be equal to 180 minus 28, collecting like terms. So 2x can be equal to this 7, this is 2, 7 minus 2, 5, 152, divide both sides by 2, so x can be equal to 76 degrees. So x is 70, since x, this place is 76, this place too is 76. We are not looking for this x here. No, sorry, I'm not using this x here. Let me call this y so that you will not mix them up. So now we are looking for x. Don't forget, this angle on the straight line, so 76 plus x will also be equal to 180. So x can be equal to 180 minus 76. So x can be equal, we borrow 1 here, this is 4, this is 7, that is 0, 104. 104, 104 degrees. Please, I plead with you, do not forget to subscribe to my YouTube channel. Thank you for staying with me. See you later.